When you know that somebody's going to come help you if you're in trouble, that knowledge gives you hope. That hope can really help you hang on and live. Things like natural disasters or places where there are no roads. Even the most capable of off-road vehicles can get stuck. What if we can combine robotics with the car, and so that the car could walk and go places where a traditional car could not go?
Elevate is a car that can walk. There's actually a lot of situations where right now vehicles meet their match based on current wheel and tire and suspension system capabilities, and we just want to go beyond that. And as soon as we start to paint a picture of some of these use cases, the light bulb goes on. If a car could walk, can it go farther and reach more terrain on Earth than a traditional just rolling vehicle?
I like to call it the ultimate mobility vehicle. It has the ability to transform from a four-wheeled vehicle into a four-legged walking machine. The mission of Cradle is to be the hub of innovation for Hyundai Motor Group. This hub is actually a network of offices to help facilitate and be the catalyst to accelerate the adoption and the use of technology, helping Hyundai transform from an automotive-centric manufacturing group to one that's about smart mobility, smart transportation.
Sundberg Farrar had been working with Hyundai on a few mobility projects. They were helping us understand emerging technologies. They were looking at battery electric vehicle platforms and emerging robotic technologies. They came to us and said, we're just interested in this idea of a car that could just go beyond standard limitations, go anywhere. And so the question started to become, why do you need this? Why do you need a car that could walk?
One of the use cases is in search and rescue. We wanted to have the ability for the interior seats of the vehicle transform from a seat into a stretcher that can be used by the rescuers to lift and carry a person back into the vehicle. We wanted something that was both lightweight as well as structurally stiff, and on top of that, cost-effective. I wanted to explore other technologies, in this case with Autodesk, about the use of internal structures within the frame of the seat itself that could provide a very high efficiency of stiffness. Math, in this instance, is beautiful.
What is super unique about this vehicle that no other robotic vehicle does, where the vehicle can move into reptilian or mammalian mode and still fold up and drive like a normal vehicle. So we need to create lightweight legs that are strong and robust, can handle the torque of the electric motors we're using, and try and lightweight the package. And we've used some Autodesk generative practices on that.
Yeah, generative design really allows us to tackle complex problems that would take somebody probably a lot more time that they have to go through different analysis. So I think it's a mind multiplier, I like to call it.
The software is helping us make an educated decision. It's forcing us to look at the different manufacturing techniques. 3D printing versus cast magnesium. There's different cost factors, there's different strength performances between the two, there's timing implications. As a car designer, the part that excites me about generative design is the change in my kind of mental focus from subtractive methods to this growing mentality. I'm growing CAD data. It's a different way of seeing a sculpture created in CAD.
With Autodesk, I hope to explore that even further. What are the tools to help kind of experiment with that digitally? And what are the tools that help to put this together in the physical format? And how do we iterate that, rapidly? I'm looking forward to the day that we can turn Elevate from sort of the concept of today to the experimental prototype of the future to the product that can be out there in the field helping people.